Okay, so as you know, we're here to do an experiment together. And last year when you did science in the 4th grade, did we learn about the scientific method? Did you all learn about that? I did. Okay, so the scientific method is the method for conducting experiments or investigations. Another word for experiment is an investigation. You're investigating a problem, trying to find an answer. So the first step is to decide what our problem is. So who has an idea, based on these equipment that you see in front of you, who has an idea of maybe what we're trying to test or what our problem is? Yes?
How much water a diaper holds.
How much water a diaper holds. Okay? So that's correct. That's going to be our problem. We're going to test its absorbency. And the word absorbency means just that. It means how much water it can hold or how much it's going to absorb. And when it gets to the maximum amount of water it's going to hold, that's called its capacity. That means it can't hold any more water and it's completely and totally full. So after it reaches its capacity, what do you think is going to happen to the leftover water, Russell?
It's going to spill onto the table.
Spill onto the table or leak out. Yeah, it might drip out, it might overflow. Okay? So the diapers are made to hold the liquid and so that they won't leak, right? That's why moms put them on babies, right? So that they don't leak out and like get everything wet. Yeah, that would be gross.
Yeah,
so after we've decided on our problem, which we know the problem is to determine the absorbency. Determine which diaper is the most absorbent. Okay. So you have some diapers in front of you, and you guys can check them out. You can touch them. You can open them up and look at them. You can see how they're structured.
Touch it out. I like this one. It has Mickey Mouse. Oh, and it's a baby Mickey Mouse. I can't wait. And a baby Mickey Mouse.
So just look at them. We don't need to be talking a whole lot. Just pass them around to each other. You can also look at the packages of diapers. If you want to read the packages and see what they say. Okay. Yes. Heavy duty. It's a play on words. Okay. So now that we've checked them out, we have to decide which one we think. Girls and boys, let me try to look up here. Remember, I'm talking. Okay. So we've looked at them. Now we have to develop our hypothesis. What's a hypothesis? Does anybody know? Yes. A prediction.
A guess.
So it's an educated guess. It's a prediction. So after we have gathered our information, and you can see these steps on your paper. If I can have one volunteer from each group to be a scribe, which means to be the writer. Okay, so you be the writer. What's your name? Catherine. So you pick your paper, name on your paper.
I never get to do anything.
Susie.
We're filming.
Susie and Catherine are going to be the scribes. So under develop hypothesis, we need to decide which one of the diapers we think is going to hold the most water or be the most absorbent. Discuss it amongst yourselves. You all have to decide. There's 3 brands. What are the 3 brands?
Huggies, Loves, and Meyer.
And Meyer. Okay? So Meyer, Huggies, and Loves are the 3 brands.
Seriously?
So let's decide based on whichever one you think looks the most absorbent or whichever.
Yeah, it's soccer. So what is it? Huggies, that's Huggies. L-E-E.
Okay. I'm not doing
This one's soccer. For asking.
Wait, it's pushy.
Alright, have we decided? Did you all make a decision on which one we think? What about this group? You think Huggies?
Yeah, the purple.
You all think Loves. Okay.
I know Loves.
So next we're going to conduct our experiment, and this is how we're going to do it. There's a big pitcher of water right here on the table. You show the water. So that's our water that we're going to pour into these smaller measuring cups, and we're going to measure 1 ounce. An ounce is a unit of volume for liquids, and you guys are going to learn about that in math next week when we do measurement of volume. So volume means how much space it takes up. So there's liquid volume, which we can do in ounces. That's our standard unit of measurement, our customary unit. So we're going to pour 1 ounce, which the very bottom line on these is 2 ounces, so you want to pour it halfway up. It's not very much at all. It's a small unit. So you guys pour halfway up to 2 ounces, and then you all do the same. And and take your first diaper that you're going to test, and it doesn't matter which one it is, but you need to know which one you're looking at. Okay. And open the diaper up, lay it flat open on the table. Ew, I'm not touching.
Too much.
These are diapers that have not been used, so they're totally clean.
Still not touching them.
Too little.
Which one are you all going to test first?
Diapers, huh?
Meyer? Okay, open it up. And
Let's
then
open up.
somebody else pour the water.
This one first. This one.
I copied one of the loves.
I'm getting you one.
So that's two, so
No,
halfway
this is
up
how
there.
it is. So this is mine.
I copied Iris.
Okay,
can we
once
pour
your
it
diaper
on?
is open, you can pour it into the middle. Open it up.
Okay. Can someone hold this open?
That's what diapers are for. Spills.
Pour it in. Now you're going to wait for 5 seconds. Count 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. And then turn it upside down and see if any water drips out.
What?
Okay. Make sure you observe and see if any water comes out. And it doesn't. So we're going to repeat. Repeat pouring in the water 1 ounce at a time. Pass the water, please.
That's Iris' spill, so it's not the water.
Okay.
Hello.
So pour the water in 1 ounce at a time.
Man, those are.
And turn it over after every ounce, and you're going to wait for 5 seconds and see if anything leaks out.
I think it's
Stop the video for a little bit. Sit, please. Everyone have a seat quickly.
Yes, I am. I'm killing a diaper.
I need a voice level 0 and eyes up here. Okay. We've conducted our experiment. We got our results. And now we need to record our data. We need to record our data. Okay? We're going to make a graph. I drew one for you on the paper. And on the bottom, we're going to have 3 marks, an M for Meyer, an H for Huggies, and an L for Love. Okay, these are our brands, and it's labeled at the bottom, your axis. Which axis is this? X. Which axis is this? Y.
That's the
On
Y.
our vertical axis, we have marks for the number of ounces that it holds, its capacity in ounces. Okay?
2, 4, 6, 6.
10, 12, and so on. Okay? Alright, so we have our results. Who can tell me how many ounces? We have different results, so I'm going to do M1 and M2. Because M1 is the first group's Meyer and M2 is the second group's Meyer. Okay, first group, Meyer, how many ounces did it absorb?
6.
6, okay, so we're going to draw a line across the 6 to make a dot. And that's where we're going to make it like a little bar graph, okay? Draw it in there. You all can do this on your paper. Okay, M2, how many ounces for the second group's Meyer blend? 2. Okay.
Do you know which one? Do you know which one's right?
We're gonna discuss what the differences mean in just a minute, okay?
But do you know which one's going to be right?
It can't be right.
They're both right. Those are the results that you all got. You all are the scientists. You conducted the experiment, so the results you got are your results. Results on experiments are not right or wrong. They're just what they are.
The results.
So, group 1, Huggies, how many ounces?
Huggies got us 2.
2 ounces. Okay, group 2, Huggies?
2.
Okay. Group 1, Loves, how many ounces for group 1 for Loves?
6. I mean, 7.
7. Okay, so that's going to be in between 6 and 8. And then group 2, how many for Loves?
2.
2?
3. You got 2 both.
2 or 3, which is it?
3.
It's a
Okay, so who can tell me why we might have differences? Who can raise your hand and tell me why we might have differences in our system? Yes.
We might have one group might have counted longer than the others, and so it would give more time to soak in.
That's an excellent idea. So if one group counted longer before they tipped it over, it would have had more time for the water to absorb into the rest of the diaper, right? What's another reason they might be
one
different?
group should have might have poured more water in there than the other group.
Okay, so the measurements may not have been exact. If we had had more scientific devices for measuring our liquids and made there was like itty bitty teeny tiny lines to make sure we had exactly the right amount. That could be a reason. So it could be from like a human error, which just means that we're human and it's not always exact. So it could be difference in measurements. What other differences did we discuss that could cause different results? Yes?
It could have been shaken when it was turned upside down.
Exactly. So when they turned it upside down, if you shake it, that could have caused the water to come out before it was
That's what
really
babies
ready.
do.
So those are all excellent reasons. And those are called controls. When we're controlling exactly how everything else in the experiment is run, in order to get the most accurate results, that's controlling the variables or the other aspects. I should be up here. We shouldn't be playing with the materials any longer. We're finished touching those. Okay? So after we've recorded our data, then we're going to write our conclusion. So what's the conclusion to our problem going to sound like? What were we trying to find out when we stated our problem? What were we trying to find out? What was our question? What were we trying to find out? What was our problem?
Determine which diaper was most absorbent.
Okay, so determine which diaper is most absorbent. How are we going to tell from our individual results, each group's individual results, which diaper was the most absorbent? Yes?
Well, both of them said Loves.
Both said Loves? Is that correct? Each group who had Loves was the most absorbent?
No. Yes.
We have 7 for Loves on this one, and 3 for Loves for the second group.
Nope.
So both groups found that Loves were the most absorbent. So when we write our conclusion, the conclusion is going to say, we found that Loves diapers were the most absorbent. And then the last thing we're going to do with our results, after we have our results, we're going to apply it to real life. So in real life, why is this information important? Somebody else. Alana.
So you know which diapers to use.
Right. Which ones to buy or which ones to use. So when you're an adult and you're a parent, you're taking care of a baby, then you need to know which brand is going to be the most effective, right? Because you want to know which diaper is going to not leak, so you don't have any messes. So that's what you're gonna. That's how you would apply it to your life. All right. Does anyone have any questions about what we did or any comments? Yes.
I like the full diapers. It's fun to hold.
You like the way they feel?
Yeah. Not
Are they heavy or light when they're full of water?
Well, they're heavier, but I bet if it's real stuff, it's gonna be heavier.
Yeah. All right. Good job. You can stop.
Build your own.
Woohoo!
Can